Good afternoon, all. Welcome to Tech Days Online 2017, led by MVPs. Welcome and thank you for joining the session Simplifying IoT Device to Device Communication with Function Apps. I have been working in IT about 16 years and recently started working with Azure Machine Learning technologies. I'm also interested in Azure IoT stack. There are so many blogs and MSDN articles available out there about IoT, mainly on device to cloud and cloud to device communication, but that's lacking. What's lacking is knowledge on simple device to device communication. In addition, traditional D2D communication involves so many components and very hard to grab the concepts by beginners. In this session, I will teach you how to create a simple device-to-device communication channel using Azure IoT Hub and functional apps. My name is Bhakti Lienage and I have my Twitter handle mentioned here at BhaktiL and also my LinkedIn account. I will submit all these this session and the code samples that I'm going to produce over the demo on my GitHub account. Let's move to the next slide. First, the agenda. In this session, I will mainly focus on three areas. Without knowing IoT, what IoT is, it's hard for us to grab the concepts that I'm going to explain. So I will do a brief introduction to IoT and what IoT is about, the history and the current state of IoT, and also some future aspects of IoT. And next section, I will do some IoT service architecture. I'll go through the service architecture. It will be very brief. I will not spend a lot of time on explaining the whole architecture, but it will be very brief. The third and the most important section is introduction to device communication. In this section, I will talk about I will talk about traditional device-to-device communication, which involves a lot of components and services. And also, in the next section, I will talk about the simply device-to-device communication, which does not involve complex architecture or not so many Azure services. And finally, I will do a demo. It will be a live demo, and you will see how simple device can communicate with another device using IoT Hub and Azure functions. So what is IoT anyway? Simply, it is a thing that has a connectivity to internet or to each other that can be turned on and off. This includes everything from your cell phone, coffee maker, washing machine, headphones, lamps, wearable devices, and anything you can think of that has a connectivity to internet. So why Internet of Things is so important? It is exploding. Day by day it is getting bigger and more complex. We had about 2 billion devices connected to internet in 2006 according to IDC, and it was about 15 billion in 2015, and it is estimated that there will be about 200 billion things connected to internet by 2020 according to IDC and Intel. And also that's about 26 devices for every human being. That is lot of things per person, smart devices per person. And the next biggest reason why Internet of Things is such a big thing and why it's important, the main reason, the biggest and the main reason, it's a big business. It will generate 14.4 trillion of value over the next decade, and there will be about 40 times more devices than people on internet in 2020. Next three slides, I'll be talking about the brief history and the current state and the future of IoT. Let's briefly talk about the past of IoT. IoT is not a new thing. It has been there as early 70s. You may not know, but there were ATMs around the country as early as 1974. They were connected to centralized location via satellites and via wired networks. With the invention of World Wide Web in 1991, millions of computers were connected to the internet via modems. Computers were mainly connected via wired networks. Then came the smart utility meters in around 2000. They were able to communicate remotely with the grid. Let's talk about the present of IoT. The present of IoT is really interesting. I'll go through few practical situations we use IoT technologies that makes our lives easier. One application is Happy Fork. It's an electronic fork that helps you monitor and track your eating habits. It alerts when you have when you have very bad eating habits, or if you are eating too fast, it will vibrate, and it will indicate, and it will send notifications to your phone. And the next example is a security system packed into a single device. It adapts to your home over time and sends intelligent information with the HD video. One of the most interesting IoT device is Big Belly. If you look at in major cities, you see these Big Belly bins which are connected to internet, and they send information or signals to the sanitation departments or the city controllers when they need to be emptied. And one of the other excuse me, interesting IoT scenario is that reflective mirror with programmable applications. When you stand in front of the mirror, it will show you whether the political news and all other information, such as stock market information and so on. So these are actually being used especially in hotels and also hospitals. The future is IoT is really exciting, especially with consumerization of mind-machine interfacing technologies like consumer EEG devices. You can capture brain activities and then convert them into electronic signals, and the electronic signals can be streamed via IoT, and then you can collect the data and run the data through machine learning process and find different hidden patterns within your brain activity. These EEG devices, consumer EEG devices, are very accurate and cheap, and they are accurate enough to be used in consumer applications. And the robots, we all know about the robots. In future, the connected robots will have ability to learn from each other and work in teams to increase the efficiency and solve scientific problems or your day-to-day problems. Now that we know little about what IoT and why it is important, let's talk briefly about the IoT service architecture. So on my left hand side, I have devices, and right hand side in red box, backend systems and processors. In between, I have included the IoT cloud. So the devices send messages to IoT Hub, and the IoT Hub redirects the messages to Stream Analytics. Streaming Analytics is a fully managed real-time event processing service that can be used to process high-speed incoming data streams, and the Streaming Analytics can be hooked into Event Hub and storage blobs. Event Hub is a highly scalable data streaming service that collects and transforms millions and millions of events per second. And once we get the data into Event Hub, and Event Hub will generate a request to web jobs. The web jobs will take care of rerouting the information or request to mobile applications, and also it will store information or the incoming telemetry into document DBs. And also using logic apps, we can publish the data, and also in addition to publishing data into backend systems, we can store the data and make use of the data using machine learning techniques, and also we can consume the data through Power BI. The next step is getting the data back to the device through mobile apps and storage blobs. The messages being passed to IoT Hub, and the IoT Hub will redirect the messages back to the devices. That completes the end-to-end message communication from device to the cloud and from the cloud to device. Let's talk about device-to-device communication. I'll explain that in the next section. So, what is device-to-device communication model, and why should we use it? Simply, device-to-device communication is device-to-cloud communication plus cloud-to-device communication. It's a one-way communication with a simple broker in between the source device and the destination device. So most of the articles and MSDN articles and other blogs actually explain this situation from device to cloud and cloud to device. But most of the places, the technologies that are being used is so complicated, and there are too many technologies being used. But in this case, we don't need that many technologies or services, because we need simple broker in between just to pass the message from source to device. So for example, just imagine opening a Raspberry Pi control garage door using your phone app. In this case, the source device is your phone app, and it just simply sends a message directly to Raspberry Pi, which is connected to the IoT Hub. So that's the scenario that I'm going to talk about. Let's dig deep into the scenario in the next slide. Let me explain what's involved in traditional device-to-device communication workflow. So we start with the device, and then the message is sent to IoT Hub, and the IoT Hub is connected to streaming analytics service, which aggregates all the data and do all the real-time analytics. And the streaming analytics service will send or reroute the message to Event Hub. The Event Hub is connected with a web service, and the web service simply gets the message from Event Hub and then redirects back into the IoT Hub. The IoT Hub is sending the message back to the device 2. That involves so many components. Yes, we need to have the IoT Hub anyway. And why do we need to have streaming analytics, event hubs, and web services? In the streamlined or simplified workflow, I am planning to remove all these 3 components and introduce something new. Let's go to the next slide. In streamlined D2D communication workflow, we'll start with the traditional systems and traditional components, and we'll start removing pieces that we don't need. So we need to have IoT Hub anyway, and just for simple device-to-device communication, I don't believe that we need to have streaming analytics. So we'll get rid of streaming analytics and also Event Hub and web service. We will replace all 3 components with Azure functions, and the function will simply broker the message that is coming from IoT Hub and back to IoT Hub, which indicates what is the destination device. Azure functions are lightweight, and they are hosted in the cloud, and you don't have to worry about any heavy applications or infrastructure. That's why we got rid of the web application. And it supports a lot of languages: C#, F Sharp, Node.js, Python, and also it enables you to execute any exe files. And the most important part is you pay only for the time you spend running your code. The other thing is that it's scalable, so if you have so many requests coming in, it will automatically scale up and scale out. You don't have to worry about managing the functions or scaling the functions out. And it supports including libraries through NuGet and npm resource manager. Also, it is integrated with security providers such as Active Directory, Facebook, Google, Twitter, and Microsoft accounts. And it is very flexible in terms of development. You can just copy and paste code in the portal itself. And also the one of the other aspect is the code is the runtime is open source and it's available on GitHub. You can download it, take a look at it, and then you can change the code according to your requirements. And this concludes the slide deck, and this is the demo I'm going to showcase you. I have two devices. One is the phone app and the other one is a Raspberry Pi. I'm simply rerouting a message generated from the phone app via IoT Hub to the Raspberry Pi. Let's get to the demo. In this demo, I will show you how a phone app can send a command to IoT Hub, and then IoT Hub is connected with Azure function, and the function will simply reroute or broker the message to the device 2, which is Raspberry Pi. Let's get to the demo. Okay, in this session I will follow step-by-step guide which I have put in the screen, and I'll walk you through each step. The first step that we have to follow is creating the IoT Hub, which is the underlying functionality. And for that IoT Hub, we will have to have two policies to in order to prevent any epoch issues. So I will show you at each step. I will go to the portal and show you how exactly that can those steps can be done. The second step is collecting some required information from the IoT Hub. So in this case, what we are trying to do here, is hooking up Azure function into underlying event hub of the IoT Hub. Azure functions cannot be directly connected to IoT hubs. That functionality is not there, so that's why we have to actually leverage the underlying event hub in the IoT Hub. So in this case, we will have to have the hub name and the hub endpoint URL. And also in the same step, we will also have to have the IoT Hub compatible connection string, which is also present in the same settings. The third step is to create the function as function. In this case, we will be creating the function with C#, and in order to get the function up and running, we will have to just like any other C# application, we will have to import libraries. So we will import libraries through JSON file. The JSON file define what libraries need to be imported into your function. So I will also show you the project.json file definition, and the next step after including project.json file is to enter the C# code, which actually receives information from source device and simply brokering it to or forwarding the message into the second device. The fourth step is creating the source device. In this case, I have created a small Windows Forms application which mimics two buttons, one on and the second one is off. This can be a phone application or this can be any other actual device as well. But for the purpose of this demo, I'm simply trying to mimic the phone functionality using Windows Forms application. The fifth and last step is creating the destination device. So in this case, the destination device is Raspberry Pi, which is connected to a LED, and this Raspberry Pi application, which is written in Node.js, is listening and connected to the IoT hub that we have created in the first step, and it's listening to any incoming messages from the IoT hub. So the workflow is that the Windows Forms application will send a command to IoT hub. The IoT hub is connected with our Azure function, which takes the incoming message and simply forward it to the Raspberry Pi device. So let's get to the portal and follow step 1. I'm on my portal page. As you can see, I already have created IoT Hub in my portal, which is called NeuroSky Brain Hub. Let's go into the hub and see where we can get those information that we will be using in the subsequent steps. So this is the section where you have all the configurations of this IoT hub. I spoke about having two policies before. So let's go to shared access policies. Simply what you have to do is click add, and then it will give you the option of creating the policy name and what permissions you have. But in this case, I've already created two additional policies, policy 1 and policy 2. So we already have that information. So let's go back and see what information we require from the IoT hub. So we have completed this step. Now we need to get the event hub name and the event hub endpoint. Let's go back to the portal and see where we can get this information. We're back in the portal, and in order to get the event hub name, you will have to go to messaging section and click on endpoints. You will see there are two endpoints already created by the system. One is for the cloud to device feedback, and the other one is to actually handle the incoming events and outgoing events from the IoT hub. So that's the endpoint that we are interested in right now. So let's click on events, and as soon as you click events, you will see all the settings that are related to this particular endpoint. Let's go ahead and copy the compatible name. Just simply copy it and paste it back into your document, which will be, these information will be used at later point. So let's go back and get the endpoint, copy it to the clipboard, and simply copy it to your document. And we have completed the 2.1 section. Let's mark it in red here. Okay, so the next step is to get the IoT hub compatible connection string. Let me go back to the portal again, and it should be available in shared access policies, and we click on any policy. Say we are using policy 1 for the IoT connection. We have, if you can see, the fourth configuration is the connection string. You simply click to copy it to your documentation. So let's go and copy it here. Okay, so now we have all the information that we require for creating the function. Let's mark this so that we will know what we have completed already. Third section of this step-by-step guide is creating the Azure function. So let's get back to our portal. In order to create a functional app, all you have to do is simply click add and type function app, which will enable you to select function app. Click on function app, and from there it will give you a list of results. Pick the first one, function app, and simply click create. In this case, you will have to give it a name. Let's say Tech Days 1. No, it's taken. Let's take Tech Days 2. Okay, so Tech Days 1, 2, 3 is available. So let's create one function app called Tech Days 1, 2, 3, and you will have to use your own resource group, or you can create a new one. In this case, I'm going to use one of my existing resource groups. And the consumption plan, hosting plan, I will simply use the consumption plan because I want to be charged based on the consumption of the application or the resources that it's consumed. And also you can pick the location, pick a location closest to your application, and then also simply pick up a storage account. Right now I have my own storage account. I'll use that and then simply click create. In this case, I'm not going to actually create one because it takes time. I already have a function app created called NeuroSky Brain, and let me take you into that function app. So this is the interface for the function app. In this function app, you can create your own any number of functions that you want. Let's wait until it loads, and you can just simply start with the timer or data processing or webhook with a webhook API, and it gives, as I mentioned in my previous slide decks, you have the option of creating functions using C#, Node.js, PHP, and so on. So in this case, I will be creating a new function so that we can use that function as the broker for our device-to-device communication. Let's create a new function. When you click new function, it will give me the option of selecting which language and what type of event that function has to be triggered on. So in this case, I'm going to choose Event Hub Trigger with C# code, and let's give it a name, say Tech Days 2017, and Event Hub name. So this is why we collected some information in my previous steps. We need to hook this Azure function into Event Hub name. So we have to go back to that document that we collected all the information and find out what's the Event Hub name that we are going to attach this function. So let's copy the Event Hub name and paste it here. And we need to create Event Hub connection string. Let's click on new, and in your right hand side you can actually add a new connection string. We need to have a new connection string for this Event Hub. Let's create a new connection string. You give it any name, Tech Days 2017. You can give any name for this that makes sense. And the connection, for the connection string, we need to go back to the document and we need to have this connection string that we created in the previous step copied into connection string text box. Create OK. give it a second, and now all the information that required for this function is entered. Let's click create. So once it's created, you will see a new function is added on your right hand side here. A new function is added, and you have a few options: develop, integrate, manage, and monitor. So develop is the section that where you actually put your C# code. I mentioned that this is a serverless architecture service, and what simply the function does is it simply runs a method, a run method in the cloud. That's all it does. So we in this case we will simply change the code, add the code to get the information from the from sending device or the source device. The message will come through a parameter as a string, and then it will simply pass that or broker that message into the destination device. So according to the step-by-step guide, we have created the function, and now the next step is to add the project JSON file which defines all the required libraries for this function. Let's go back to the portal. Okay, so in this portal, if you look at your right hand side top, you have a function, you have a link to view files. Click on view files and you don't see the project JSON file. So let's create a project JSON file. Click add. And press enter. Okay, and we have to in this case we will have to include Microsoft.azure.amqp ASP.NET Web API client and Azure devices libraries, which is required for sending information back to a device. So let me copy that JSON into the screen, and let's save it, and let's look at the log. So if the importing JSON file is successful, you will see the message compilation succeeded in the logs. Next step, let's look at the next step. So we have completed this step here. We have created the project JSON file, and the next step is to enter C# code. Let's go back to the portal. In here, your function runs in run.csx file. So in this case, we will I will copy the required C# code that that brokers the message into from source device to destination device. I will publish all these code into a GitHub account, or else I will just do a blog post on this topic. Let me copy the C# code. And once you copy it, you simply save it. You should see in the logs if it failed or if the compilation was successful or not. You should see it as soon as you hit save. Let's hit save and pay attention to the logs. It says the compilation failed. So let's see what the problem is. Okay, so the problem is the code that I copied. It actually it's waiting for it's looking for device status, right? So this function doesn't know what device status is. We have to define what are the information, what are the input parameters for this run method. In order to do that, we have to go to integrate, and in the event parameter, I will by default it says it's my event hub message, but we will have to change that to device status, which we are using in the code. So let's change it to device status and save it, and let's go back to develop and save it. Now it should try to compile, and again there is a okay, I think I'm missing one curly bracket, so let's try it again. Okay, at this time it succeeded, and I think the function is now ready to be executed. Let's pause for a second and let's go back to the step-by-step document. So we have created the Azure function. We have uploaded the project JSON file which imports all the required DLLs, and we also entered the C# code, and the C# code is compiling well and the build is successful. So now the next steps we have to follow is the create source device and the create destination device, so that we can see the end-to-end communication. And let's mark this line as completed. Fourth step of this step-by-step guide is to create the source device. Let's head over to Visual Studio and see how we can create the source device. In this project, I have created a small Windows Forms application with two buttons on and off, which mimics a phone application, but it can be anything. It can be a phone application, it can be a desktop application, or whatever the business requires. So as you see, it has on and off button. In my on button, I have implemented a simple send event using the device client object, populating a property object which has source device ID property and target device ID property, a command which is set to on button on click event. In button off click event, I'm doing the same thing except the command is off. Let's start this project and see how the messages are being passed into the IoT Hub. So now the form is running. Let's open the Azure function and see if we get any messages from the form. Let's click on, and we should see the message coming into the function. See, in the function I'm just simply logging the connection string, source ID, target ID, and the message. So I see the source ID as the phone app, because that's the originating device, and this is the Raspberry Pi that I'm sending the message to, and this is the command, and it's on. Let's click off and see if we get that message into the Azure function. Off. Yeah, we get that message into Azure function, and it is actually sending the message, the command message, to the target device, which is the Raspberry Pi. So in the next step, we'll head over to the Raspberry Pi device and see whether that message is being received by the Raspberry Pi. We'll mark number 4 as done, and let's go to step 5, which is creating destination device. So the Raspberry Pi is the destination device, and I have created a Node.js application to receive commands from the IoT Hub. So the Node.js application connects to IoT Hub and waits until it receives any commands from the IoT Hub. Let's head over to Visual Studio Code. In this Node.js project, I'm using wiring Pi module for controlling GPIO of Raspberry Pi, and everything else is standard. And also I'm importing Azure IoT device module so that it can connect to the IoT hub. I have hard coded the connection string parameter here, and it is connecting to our IoT hub, and also the device ID is marked as RPI. What it does is it simply receives the message, and then it passes the message. In the message body, it will have the command that we passed as a JSON, and then it evaluates what's the message is. If it is exit, then it will stop receiving message. It will revert to stop receiving message function. If it is on, it will set the Raspberry Pi pin to 1. If it is off, it will set the Raspberry Pi pin to 0. We have configured the Raspberry Pi pin for pin 7, and the pin 7 is connected to the LED. In the final step of this step-by-step guide, I have logged into my Raspberry Pi, and I'm going to start the Node.js application. Let's wait a second, and it should connect to the IoT hub, and it should wait for any commands from the hub. Now if you can see, the LED is turned off. The Raspberry Pi is connected to IoT hub. The LED is turned off, and I'm going to click the button on my source device. We should see the LED is turning on, and also at the same time we see the log from the functional app, and we see the message is being received by the functional app, the Azure function, and the command is on. Let's turn the LED off remotely by clicking off. We see that message also sent to IoT hub, and it's captured by the functional app using the Azure function, and also the message off was sent to Raspberry Pi. So that concludes the end-to-end demonstration. The command is generated from the source device, and it was sent to the IoT hub. The IoT hub captures that command or the string which was sent by the source device, and it simply forwards that command to the destination Raspberry Pi, and the Raspberry Pi acts on the commands received by the IoT hub. That concludes the end-to-end demo. Let's update the step-by-step guide. The step 5 is completed, and we'll mark that as completed. This concludes the session on simplifying IoT Hub device-to-device communication with Azure Functions or Azure Functional Apps. I will include all these steps into a blog post along with source code and configuration steps, and all the source code will be uploaded into GitHub account. And also, please feel free to drop me a line. You can use my email or Twitter handle to communicate with me. And finally, let's head over to the last slide where I have all the references. Finally, here are some links for your references. The first one, the blog article, is for developers. It's a really good blog article. And also you can refer to IoT Dev Center. And in addition, there are so many source code and articles on GitHub repo. Source code is really good. C# source code, .NET, Node.js, and so on. And also you can learn a lot more on Azure Functions at Azure Function Dev Center. Finally, you can head over to Microsoft Virtual Academy. They have a lot of videos on IoT and also Azure Functions. You can take courses at your leisure. Last, the end-to-end sample solution will be blogged at risingskyline.com. I hope you enjoyed the session. Thank you very much.